Okay, I think the rest of the colleagues can find us on the way. Let's commence with the last keynote session for the day. And the keynote session, we are going to have two sessions in succession. There will be a keynote for about 30 minutes. And after that, we will have another session, which is the Analyst Crossfire. So the Analyst Crossfire will be focusing on technology vendors telling us about their technologies, and the facilitator will tell you more about how is he going to squeeze out those answers from the vendors. But let's do the first one. My job now for this, I'm not going to be giving this keynote. I'm just here to introduce the speaker. And I would like us to welcome Addison Snell to stage. Addison Snell. He is the president of Intersect 360. This is the company that does a deeper analysis about the technologies and looks at the trends. Addison has been doing this, I don't know, for so many years. But one of the things that Addison prides himself about is that he builds puzzles. That puzzles.
This is true, crossword puzzles, yes.
Yeah, something like that. And he can say a little bit more about them. But his profile is there. I'm not going to go deep into it. Addison has been doing this for the past 8-9 years here in South Africa, and not just only here, also at the supercomputing meeting in US and supercomputing in Germany. So whatever he says, listen to him. That's where you have to go. Addison, over to you.
Thank you very much, Happy. Absolutely thrilled to be here at the CHPC National Conference and back in person in South Africa. I think this is a wonderful conference, and thank you, Happy, for the nod. I do have a hobby of crossword puzzles, and in fact, today I have my third crossword puzzle published in the New York Times. So those of you who subscribe to the New York Times crossword, you can check the author. That's mine today, of all things. So I'm actually quite proud of that. You can tell me how much you hated it later on. That's not what I'm going to do here now. I'm going to give a quick market overview, not our full market overview like we've done in webinars, but some excerpts from some of our recent studies and also our what we called our grand unification model of market sizing this year, looking not only at high performance computing and AI, but also hyperscale and where that fits in the broader scope of enterprise computing. I'm based in Mountain View, California. I'm here with my colleague, Dan Olds, who's our Chief Research Officer. I don't see Dan in the room right now. He is probably with the students. Dan is heavily involved in student cluster competitions, and we're great admirers that Happy and Werner take such a great lead with the students in developing the next generation of talent in this space. Dan is one of the judges of the student cluster competition, and no doubt he's there rather than here because he's seen me speak before. As I said, I'm based in the Bay Area, so I am jet lagged right now and I have way too many slides, so buckle up, this is going to be fun. Starting with some trends that we're seeing in processing elements. I think this is one of the hottest areas of the industry right now, looking at CPUs, GPUs, accelerators. We'll be digging into this in the panel later. The upshot of this is that we're seeing a lot of adoption of AMD, of course, coming into the market. We haven't seen a lot of adoption in volume yet of ARM, and this is, of course, is going to be very interesting because NVIDIA is, of course, moving in with its Project Grace and is going to be a CPU competitor as well as an accelerator competitor. We have seen a lot of penetration of AMD with EPYC. Now, this, of course, doesn't include anything with Genoa yet. These are installed base surveys, so things take a while to percolate into the market. When we look at accelerators, they have become quite common across HPC users. What we find is that 81% users in our last survey, which is almost a year old now. We're getting ready to rerun this survey in the month or two ahead. 81% have accelerators somewhere as part of their environments. But then when we look at what proportion of the nodes that is, it winds up being about 29% of all nodes across the HPC market have accelerators installed somewhere. The vast majority of those are GPUs. Those are projected to continue to grow. This is a lot of the influence of AI coming into the market, which is pretty GPU heavy, and we do see a lot of adoption of GPUs in this space. This is a NVIDIA-dominated market. The vast majority of these have been NVIDIA GPUs. NVIDIA controls not only the hardware, but the software ecosystem around this right now. We are seeing penetration and planned penetration of the AMD Instinct GPUs. We did not have Intel Ponte Vecchio in the survey when we ran this the last time because it's just too early. They weren't in the market yet, and people, all we do is put a 0 on the chart. This is really, this next survey is the first time we can really probe on the planned adoption of Ponte Vecchio as a GPU. We certainly won't have an installed base yet. That's still going to be a 0 on current, but we can look at what people's plans are around that. The reason this is relevant, and I'm going to come around to this on the panel, is what users tell us in these surveys and others showing other data not shown here, is that what people are really the most comfortable with right now is a combination of x86 CPUs, whether it's Xeon or EPYC, take your pick, x86 CPUs together with NVIDIA GPUs. But as analysts in this space, one thing we can get a sense of is long-term trends. And one of the very long pendulum swings we look at is the swing from standardization to specialization. And standardization, we kind of hit the maximum with that in the era of the Beowulf cluster about almost 20 years ago now. And the idea of a Beowulf cluster was it was the maximum in standardization with an emphasis on portability. I had to go through the pain of putting my code into MPI once, but once I did that, any cluster was the same. It could have come from IBM or HP or Dell. A cluster was a cluster was a cluster, and you'd get the same performance anywhere with great portability. We've gradually been moving away from that toward more and more specialization. And we're now about a generation away from having the SoCs from all the different vendors get us to where you can choose between an all Intel environment integrated as an SoC, an all AMD environment, or an all NVIDIA environment encompassing both CPU and GPU. This will be then the far apex of specialization with an emphasis on individual application performance, but sacrificing the notion of portability, where I now can't just lift and go from one to the next. Now, I'm not saying one is better or worse than the other, but that's the way that this is going. And users are now going to say, well, they're going to have to trade off something, because I can either keep my x86 but give up the GPUs, or vice versa. If I stay with an NVIDIA GPU, I've now got to move to an ARM CPU. And handicapping this horse race is difficult because we have NVIDIA with the domination of the GPU ecosystem, including software, Intel with a legacy of leading in the CPU side, including the software ecosystem, where they have a lot of the surrounding software and middleware comes from Intel. But AMD in the middle is the first to market with both in a combined form factor. AMD has that today with Frontier and other similar products, and you don't have Intel yet with its Falcon Shores, or NVIDIA yet with its Grace Hopper. So it's going to be fun. We'll watch and see what happens. Another thing that we're watching is performance versus expectation for end users in the market. We find that people aren't always happy with the level of efficiency that they get out of these systems. And in fact, 16%, which isn't a majority or anything, but it's not nothing, 16% report moderate or major performance issues with their clusters below expectation. And when we look at the sources of that, I/O and memory often come up. We're starting to see this new category of hardware application mismatch. A lot of this has to do with we look at how people are configuring systems. And in particular, we're seeing heavier and heavier GPU configurations as we try to balance more machine learning in HPC environments. In fact, when we look at the histogram of how those are configured now, the most common, the top bar in the histogram right now is at 4 GPUs per node. And that's very quickly gone up from 1 through 2 to now 4 is the most common. We're seeing a fair amount of 8 and more than 8 GPUs per node. The thing is, this is where HPC and machine learning, as much as we've talked about the convergence, this is where they're starting to diverge, because most of your HPC applications are going to be happier with 2 GPUs, 1 GPU, maybe 0 GPUs, depending on the application. But your machine learning kind of wants 8, 12, 16. And we're seeing a lot of people putting in 4 as a medium configuration that makes both sides equally unhappy. So that must be the best thing to do. This is leading to discussions around things like composable infrastructure. Memory is another component where regardless of GPUs, as we've seen more and more multi-core systems, the amount of configured memory per core has stayed relatively constant over the last 10, 15 years. It's actually gone up slightly. But if you figure the amount of memory per core staying relatively constant and the amount of cores per socket going way up, the amount of memory that's going into these systems now is really going up to where memory is a huge cost component in a system, as are GPUs. That's why things like composability are coming up now as more common topics as to whether there's a possible way to do trade-off, configure fewer memory or GPU components overall, and somehow share them across a system. 15% of people say their accelerators are not highly utilized. 30% say they're not as highly utilized as expected. 33% say that those are compute islands that are not well accessed by the rest of the system, which isn't to say they aren't buying them. They're buying them in droves. It's a major driver, but it creates these other challenges as part of a system. Okay, with the rest of my time, I'm going to bridge to this other market sizing thing, but rather than just a traditional HPC AI market size and forecast, I'm going to talk about this grand unification model that Dan and I worked on this year. Now, all of these are going to be 2021 numbers. I get it that that's now almost a year old, but what are we going to do? It's still 2022. I can't report on that full calendar year. You just have this conference at a weird time. And in fact, we don't get the new numbers out generally until April of the next year. So we've got about 5 more months before you'll really see the new market numbers for us. But this does establish how we're setting this up. Grand unification, what we mean by that is we've been tracking the high performance segments of the market. That's what we do at Intersect 360 Research. We're not general enterprise computing analysts like a Gartner or IDC. We cover these high performance scalable areas that are not well covered by the big box kind of analysts. So we don't generally do all of enterprise computing. So we say, well, we're only doing the HPC and AI and hyperscale parts. Why do a grand unification model? Well, the hyperscale, for the most part, has grown to be such a dominant share of enterprise computing that we found that despite how often we put out hyperscale numbers, people weren't getting the magnitude of it relative to other enterprise computing. And if we were going to show it as a proportion, then we had to do what's enterprise computing as a whole, which led us to, all right, at least at the top level, we have to size enterprise computing in general, come up with our own number for that. That's what we did here with all data center spending for 2021. We sized at $235.1 billion. That's essentially for the hardware and software going into enterprise computing. This is an independent number done by us. And the reason for the strange size of weird corners here is this is done where every one of these cells is $100 million. So there's 2,351 little squares in this chart so that we can start dividing them up proportionally. Everyone with me so far? Not jet lagged? Okay, that's what we're going to do is start cutting this up. When we do that, here's what that looks like. Hyperscale spending accounted for half of all data center spending in 2021. Well, just shy of half, 49.8. So I can't say fully half. It's 2/10 of a point shy of being half. But okay, half of spending is hyperscale. The on-premises HPC and AI portion is up here. That's this $30.8 billion. The rest of on-prem enterprise, $89.3 billion. The on-prem HPC and AI is growing as a proportion of all on-prem other enterprise computing, mostly because cloud pulls more strongly from this than it does from this. So as more enterprise computing goes over to cloud and less, some HPC does certainly, but not as fast as the other, then HPC grows as an overall proportion. The reason for the two different colors here is because the medium blue here, this 29.6 billion, that's the part that we've been counting for years as high performance computing. It's identifiable as a high performance computing budget. In many cases, in most cases, in almost all of them, at this point, it includes at least some machine learning. There's a lot of mixed machine learning in those HPC environments. This darker blue 1.2 billion is new. This is what we're counting now as an on-prem pure AI budget, which is to say it is not associated with a previously existing HPC budget. It's created new out of whole cloth. Someone is doing AI that has not previously been doing HPC, and now they're buying some on-prem infrastructure for it. This is the first year that we counted enough of that to warrant calling it out separately. There's plenty of that in the cloud, but this is on-prem spending. And we're showing both the traditional and the expanded views for our clients. Hyperscale, on the other hand, this $115 billion. The first thing I have to say about this is the bottom point, is that I don't really care for people using hyperscale and cloud as synonymous as cloud service providers. To us, hyperscale is a superset of cloud. Cloud service provider is one thing that a hyperscale company can do with its infrastructure. But if you think about it, even among them, Amazon is much bigger than AWS. Right? Microsoft is much, much bigger than Azure. Google is way bigger than GCP. And then you get into other companies like Meta or Facebook or ByteDance, which is TikTok, and Twitter and Apple. These aren't enterprise cloud companies, but they are hyperscale companies, right? That have hyperscale internet infrastructure that goes into this space. So what we're talking about here is the hyperscale market to build these big data centers. Cloud serving is part of what that does. The top 10 companies in this space account for over 80% of this spending. It's actually really probably between 85 and 90, but we can confidently say it's over 80. So it's really top heavy in this space, is that close to 90% of the spending coming from 10 companies. One reason it keeps growing so much is that we're creating data center markets out of things that didn't used to be enterprise markets. When you're email and your music and your calendars and your photos and your smart thermostat are all going into the cloud, that's making new data center markets, right? Playing video games didn't used to be a data center market, and now it's actually a pretty big hyperscale component serving out massive multi-video games. Now, there's also a cloud component. We can look at the HPC in the cloud. We can look at the pure AI in the cloud. Pure AI has a heavier pull toward cloud than the rest does, but there's still more spending of cloud for both of these that then also bleeds over into hyperscale. But the bigger thing to look at that people really miss is when we look at AI training, the AI training done by the hyperscale companies themselves dwarfs the rest of the market, which is to say, if you're at Microsoft or Meta or Google or Amazon, they're doing an awful lot of AI training for their own purposes. I'm not talking about serving out AI in the cloud. Okay, yeah, there's a lot of that. I just talked about that. But here we're talking about $12.8 billion spent on the infrastructure to do AI training by those hyperscale companies for their own purposes. And that has a huge effect on the rest of the HPC market. One more chart to try to get across the magnitude of hyperscale in this space. If a large-scale national supercomputer tends to cost a couple $100 million, if you spent $200 million on a supercomputer, it might not be number one on the top 500 list. You'd probably make the top 10. $200 million supercomputer. Let's put a pin in that one. There are 10 hyperscale companies that reliably spend over $1 billion on infrastructure every year. So that's 10 times your $100 million supercomputer every year going into 10 hyperscale companies. 4 of them spent over $10 billion in 2021. 2 of them spent over $20 billion. That's a factor of 100 more than your $200 million supercomputer, right? It's times 10 and then times 10 again to get from 200 million to 20 billion. That's the order of magnitude that we're talking about here. And if you took the 2 largest hyperscale companies' data centers worldwide, they would cover 25 square miles. Now, I had to pick an island. I chose Manhattan. Sorry to be Americentric, but a large supercomputer like a Fugaku or Frontier, you could picture that'd fit in a city block, right? How big would a supercomputer the size of Central Park be? These 2 companies' hyperscale infrastructures would not fit together on Manhattan Island. It's that much computing. So the order of magnitude difference between what goes on in HPC and what goes on in hyperscale is something we've been trying to communicate for years. And I think we're still trying to get there on how much influence there is. Okay, so a couple more charts. We do the verticalization of HPC. We tend not to include hyperscale in this. That's a separate thing. Biosciences has done very well throughout the pandemic. That's natural. The one that didn't do well and then did do well that's interesting is entertainment. People stopped going to the movies in 2020. It had a big down year. By 2021, the entertainment industry had largely pivoted to a lot of online streaming. And the features that were getting produced then were really heavy on the visual types of special effects that drive underlying high performance computing. Entertainment had an up year in 2021. What else do I want to say? If we include the pure AI, there's not a big difference other than there is a noticeable bump to financial services. Financial services doesn't get enough recognition for being the vertical market that has the most on the ground real deployments in machine learning. It's where the money is, folks. We can talk about self-driving cars and personalized medicine. You're going to see large scale personalized interest rates first. There's too much money there. There's a lot of AI going on in financial services. Now, if we did include hyperscale as a vertical market, just for the AI they're doing, it would then become the biggest sector by quite a bit. This is why we usually ignore it. For most of our clients, we refer to it as the Chuck Norris segment. You don't go and find it. It will come and find you. It will tell you what it wants and it will, come get it. The server classes I'm just going to show only because the interesting thing here isn't the growth in servers, which does get back to a healthy normal growth rate as we come out of the pandemic. But look at this entry-level HPC system line down here. It's actually the first time we've ever shown a negative growth rate in any HPC segment in a 5-year forecast. And this is the effect of cloud. Cloud, where it exists in HPC, is pulling more heavily away from the entry level and mid range than it is from the high end and supercomputing. And it's actually flattened out and now pushed the entry level negative. So hyperscale is having huge effects across HPC. We'll talk about this on the panel through the rise of machine learning. It's really the hyperscale companies that drove that and now have introduced it through HPC. We're seeing languages in HPC that are coming out of the hyperscale area, not just Python, and there's a lot of Python now, which is dominant as a machine learning language. It was showing up before that, but now Python is a top tier language along with C++ and really eclipsing Fortran. In this space going forward. But Go and Julia are showing up in HPC now as languages designed in the hyperscale area and now migrating into HPC. Product design, product availability, it's only natural if you're designing products for high performance computing, whether they're processing elements, servers, storage. If hyperscale is a target market for you, it's easy to start getting really influenced by what they want very quickly. This is beyond elephant hunting into whale hunting. You get one of those as a customer, it becomes a market maker for you. Talent acquisition. If you're a young programmer out or computer scientist out there getting a job, the hyperscale companies are hiring a lot of people. And as much as we'd love to keep you here, you're going to get job offers from them as well. And it's a question of what you want to do for a living and what really drives you. But talent acquisition, hyperscale has a huge effect on HPC. And the last one is not to be underestimated either: international trade and domestic technology and development, particularly with regards to AI. And we're going to talk about, as one of the speed topics on the panel, the national sovereignty issues around technologies for supercomputing and AI development, and how that's starting to look internationally. I value these international companies, international conferences, and the ability to trade ideas in a borderless HPC community, but that's not always the reality in the political side of the fence. We are seeing a lot of new trends in software development. C++, I already mentioned that, Go, Julia. I'm going to kind of skip through this. Reactions from SC22, processing elements, again, was where a lot of the news was. AMD was really riding high going into SC22 because of its Genoa launch of the new EPYC CPU, but Intel had its own more of a marketing branding launch with Max, although it did release some details around the high bandwidth memory that were really popular. I think people are looking forward to HBM in this space, and seeing some comparisons between the new Sapphire Rapids and EPYC and Ponte Vecchio versus Instinct. And if we can get Grace Hopper into that, it'll be really interesting to see how those stack up. NVIDIA was clear at supercomputing that its primary focus currently is on AI and hyperscale. NVIDIA went into supercomputing and gave its booth space to its two biggest cloud partners. There was an Azure side of the booth and an Oracle Cloud side of the booth. And it's impossible for me to stand up here and say that's wrong when so many of the new Hopper GPUs are already being consumed by Meta going into that research supercluster. I had Shubho Sengupta on my plenary panel from Meta talking about that research supercluster as one of the premier AI facilities in the world. And that's where NVIDIA is focusing right now. And that was noticeable at SC. We talked about networking, servers, storage, liquid cooling, low power. Rather than me talk about all of these things here, I will say that I'd rather get to the next part of this session, which is the Analyst Crossfire panel. And I can put these questions to my panelists. In fact, I already warned them about that. And my panelists can start coming up here and taking the seats while I introduce the concept of this panel. This actually goes back, I want to give credit to Rich Bruckner, who passed away a couple years ago. He was the lead editor and founder at Inside HPC, one of the leading publications in this space. He was recognizable walking around the industry in his red hat all the time. He did not work for Red Hat, he just owned a red hat, and it was kind of his thing. And it was at a bar conversation at the ISC conference one year that Rich, heard me having a conversation with people about all the things that we were covering as analysts. And he said, wouldn't it be fun to have a panel where you took all the topics you're being asked to address as analysts at a supercomputing and then just turn them into questions for other people? That's where my panelists don't even want to come up. Where is everybody? Get up here, people. So we're going to have... let's see. It's not going to be Ahmed Al-Jeshi from Intel. Jean-Laurent Philippe is last-minute substitution, so that will be Jean-Laurent will be on the panel. The others are as listed: Yossi Avni from NVIDIA, Olivier Blondel from HPE, Rick Koopman from Lenovo, and Ryan Rautenbach from Dell. And we're going to go through some fun topics. The way this will work, nope, you're taking my chair. That one's mine. I'm in charge here. Sorry, some of these fonts got screwed up here. I think you can still read them anyway. This is what we're going to do. We've got three main top topics there: the effect of hyperscale on HPC and AI, HPC in the cloud, standardization and specialization. I already talked about some of those things in my talk. We're going to take a leisurely time of 10 minutes each on each of these topics. Then we're going to go to a speed round after that. We're going to do 5 more topics in 5 minutes each. And if we're really good at this and we get down to the end, then we'll be able to take some questions from panelists. One of the other guiding principles of this panel that I found in my many years of moderating panels, and see if you wind up agreeing with this, is as a moderator, I find that the less time I give someone to answer a question, the better the answer gets. If someone gets 20 seconds, it winds up better than a 20-minute answer. So we're going to give this a try. And we'll dive right into the first topic with my panelists here. I got to see if I can still advance these slides. Terrific. Oh, shoot. Some of these are still overflowing. Okay, I thought we'd fixed all these, but never mind. The effects of hyperscale on HPC and AI. I already introduced this topic, fellas, but you're looking at hyperscale as vendors in this space. You can sell regular HPC, you can sell the hyperscale. What do you see as the effects of hyperscale on what we've been measuring as the traditional HPC AI market? Do you look at them as the same market, different markets? How does the one affect the other? And in the end, is hyperscale good or bad for HPC and AI? I'm going to start down at the end, Rick. We'll come this way.
So Lenovo is selling into both areas, both in hyperscale and in high performance computing. So we definitely notice the influence of the growth of hyperscale. We notice it in the level of attention and the focus from the vendors that we integrate into our solutions on the network side, on the processor side, on the GPU side. It's a much bigger market. It's growing extremely fast. And that changes priorities. It changes priorities. It is where HPC used to be in the storefront of innovation, of new additional capabilities. We do see that very often the focus now is on the hyperscalers, and we're a little bit in a backseat now from an HPC perspective.
And I'm going to come down here to Olivier next. I'm going to do the system vendors before I do the processing element vendors.
We see it as it's a way customer wants to consume HPC. Okay, so we define solution based on customer projects. So we have project where we partner with them, mentioning like UKMet, for instance, partnering with Microsoft, or some customer have budget to consume on a yearly, monthly basis. So this is why we developed GreenLake many years ago. Okay, now it's much more mature. And what is it? It's a cloud hyperscale owned by the customer because it's in his premises. So we overcome the issue of data sovereignty, for instance, because the data stay on the customer premises.
You're a topic ahead on HPC in the cloud, but that's all right. They are related, so we'll get there. Ryan?
Thanks. So from a Dell perspective, we work very closely with the larger ecosystem, I think very similar to the colleagues that have gone before me. And it's about commoditizing commoditizing the HPC elements, and then how we actually leverage our partnership between on-premise customer usage and hyperscale, and then making that a seamless transition where we can actually leverage bursting into these hyperscale infrastructures to gain more resources in the infrastructure.
All right, I'm glad I did the system providers first, because I got to say, so far, those were really friendly political answers, and I'm not sure how much I buy it, right? That, okay, we're democratizing it. We want to just do it however customers want to buy HPC, and it's all the same to us. Really, the hyperscale customers are the same as your traditional HPC customers? Rick, you're shaking your head, so I'm going to let you try again.
They're definitely not the same. So
okay,
there are some similarities, but they're not the same. They're not the same on a scale. They're not the same on what level of network connectivity is going to be needed for intercommunication between the compute nodes. They're not the same from a level of data bandwidth that you're going to need for reading and writing your content to your storage environment. So they're not the same. And so we need to make sure that we keep the attention of those parties also on high performance computing, because we need to evolve those capabilities also the same way as we're seeing now happening with hyperscale.
That answer was so much better, they turned the lights on for it. All right, Yossi, what do you think? You were shaking your head earlier too.
Yes, first, my colleagues were very politically correct, and Happy asked me to behave, so I promised to try.
That's not happening, and Happy knows it. That's why he tried warning you, but you wouldn't have put him on this panel if you wanted to behave.
Thanks. I think in one sentence, economy of scale. The very fact that thanks to the hyperscalers, we managed to come up with such a volume of products out to the market has a huge impact. Just to give an example, in the last quarter, we shipped 3 million adapters, 3 million adapters, which means price goes down, development of software goes faster, development of hardware goes faster, GPUs everywhere. We work, as my colleagues mentioned, with all of the hyperscalers, with the majority of the HPC. I think it's hyperscaler is very good impact on HPC.
I heard someone in this industry once say, the more you buy, the more you save. Have you heard that before? All right, we'll get to that.
Said the person who gets the best pricing in the world.
The more you buy, the more you save.
Cambridge University.
Where did I hear that before?
Jensen.
Laurent. Yes, I know.
So I look at it from a different perspective. I work a lot with my team on tenders. And when we need to do benchmarking with the hyperscalers, it's easy. They already have the hardware, usually. So we can really measure and we don't need to estimate. So that's already a good thing. Then when it's time to deploy, it's already there. So that's good. Yet, you have to choose as an end user what they have. And if they don't have the right GPU or the right fabric or the right thing for your tender, then that might be a little bit more difficult. But they can work on that by giving some better pricing, maybe. The other thing is that once you have this agreement or this contract with the hyperscaler for a few years, you are not blocked on one generation. They will certainly have new hardware in the next 6 months or 1 year, and in the next few years, they will have future generations. So that can be also something that can be very positive for some of the users who have to run applications, and if they have it on-prem and they don't want to change it for another 4 years, then the hyperscalers can be giving them some good solutions. Intel works with all of the hyperscalers, and we are happy with them looking at what we bring and choose something which is differentiating so that the end users have even more choice.
Of course, you're all working with all the hyperscale. I love that you were saying you wanted to buy a Hopper GPU to do your benchmarking against earlier. You can't get one because Yossi is shipping them all to Meta, right?
You said it, but we can't buy it.
What, that's not true?
I'm saying nothing.
Is Meta getting any Hoppers?
No comment.
Uh-huh. Okay. I said it as an analyst. All right, what else? I mean, no one's answered yet the last question on the slide. Ultimately, then, is hyperscale good or bad for the traditional HPC market?
I think I gave a very clear answer. I think it's very positive for the HPC market. Economy of scale.
Because it's driving down the cost of components.
Driving down the cost and accelerate development for both software and hardware.
Any other differing views on that?
I would prefer to go the other route and say.
Well, good. Then do
so,
it. You're holding a microphone.
Not so great for us as commodity traditional HPC providers, but also the where the data lives is where we want to really get to. So having these hyperscalers is to an element a competition to ourselves, but like Yossi mentioned, I mean, it does drive down the cost of components. So that is the good piece of that. Adds additional competition for the market, which obviously gives our customers chances to look around. So,
It can be good, it can be bad. And the good thing about it is that, as Jossi mentioned, the economy of scale has an impact on product cost, or should have an impact on product cost. On the other side, on the other hand, what happens if after a new product introduction, like new processors, new accelerators, and a hyperscaler knocks on the door and says, "I want to have 200,000 of those adapters." What happens with the 100 rack supercomputing solution that you want to deliver to a customer? Priority is influenced by economy of scale also. So it's up to us as vendors to work closely with those parties to make sure that we also get the level of attention.
Product development is influenced by it too, and I'll hit that for just a second. I want to check in on Olivier, though, who I cut off earlier. Do you have anything further you want to chip in on this?
Good or bad, it depends on the market segment. For some market, we are using HPC or AI as commodity. I'm thinking about automotive customer, for instance, when they're using hyperscaler for some burst activities. It's good because they have their own system, and then for extra capacity, they go on the cloud, okay? But for some market like education, academics, HPC system is seen as a flagship, as a way to attract grant. So it needs to be on premises. So hyperscaler, for me, have a difficult play in that scope.
Yeah, I think that still looks at hyperscaler primarily as in the nature of being a cloud provider. And I'm trying to think of it more broadly than just that myself. But I like this point about the influence they have on in terms of what they're asking for. It changes our whole language of how we talk about systems. I was blown away going to an OCP conference years ago where they were talking about 46U racks or whatever. And I'm like, really? That sounds tall. No, they had just changed how much a U was. Like, you can do that? I used to know how a rack unit was a certain amount. No, they just change it. I used to know how much a flop was. I don't anymore. You tell me how many flops something has, I haven't a clue what that means anymore. We're introducing different levels of precision. And, okay, I get it. Single precision, half precision. And then we get into some of the funny ones that we can, really change what constitutes a flop. I mean, I guess there are places that's good for HPC too, and we should talk about how high precision you really want to have in your model, but it's a new way that we haven't talked about that before.
So I'd like to add that indeed we see a lot of our customers, end users, so our customers, using HPC and AI in a different way. Like they do simulation, then they do a little bit of AI, then they do another simulation, and then AI again. And they can do that with hyperscalers, maybe to test it, and then they can implement it on-premise or at hyperscalers. But I agree that there are some good things that are coming with the hyperscalers because they have the scale, and the end users can test at a larger scale before they deploy or before they buy or before they choose.
Well, if this panel runs long, I'm going to say I just was using a traditional type of minutes. I was counting minutes in bfloat 8. Let's go on to HPC in the cloud. Are we going to start to see a leveling off of cloud versus on-prem in HPC that involves repatriation of jobs and data? All right, and here we go. We can talk about GreenLake and other types of cloud managed services, not just GreenLake, but we're getting Dell Apex into the market. Lenovo TrueScale is coming in, and those aren't even the only ones. Fujitsu has an as a service, so does Penguin, so does Atos through Nimbic. So we're seeing a proliferation of these types of things. I'm interested in talking about that role. And what about facilities outsourcing? That's not really cloud either, but we're talking about someone else managing my facilities. So let's start at the top with this HPC in the cloud. That has had a lot of growth throughout the pandemic. I think it goes beyond just the idea that cloud is awesome and people finally realized it. What cloud does really well is help deal with uncertainty. We've had a lot of that in the last couple of years. What are your views on HPC in the cloud and how that's going to balance out the next couple of years? And go ahead and start, Olivier, because you were anxious for this topic.
What is HPC? It's crunching data. So we need to think where data are. And that's the main concern of many customers, which is where my data will go. Always remind something in Germany will happen when they cancel a contract with Microsoft because Microsoft was not able to ensure that the data will remain in Germany, for instance. And so that's the main thing. So that's why, I mean, which is not new, which we 10 years of experience with Greenback, we come up with it's a go-to-market, a way to consume HPC with answering all the concerns of a customer about where my data will be, how much I will consume. You don't pay for the infrastructure. So we manage the technology refresh, for instance, always have access to the latest technology when available. And the data on premises, and it can be claimed as my own HPC as well. So this is how we overcome, and then we manage it as a cloud.
Ryan, you're nodding along. You're going to jump on that?
Yeah, sure. I think maybe just to localize it, South African context, because cloud great, and I think having the capabilities of spinning up machines and getting working immediately is great.
Take Rick's microphone.
Thanks.
Share that one.
And I think what we see in terms of HPC is the convergence of HPC, AI, and data analytics going into the future, and using those kinds of commodity systems on premise, typically for data gravity purposes, and using it for more use cases really expands that. Where in the cloud, from my perspective, it becomes a cost conversation. From a South African context, it seems to be a lot more expensive to do that today versus how we can do it in the traditional sense.
No, it works. You just got to be pretty close to it.
Okay, let's try then. So, you know, the HPC in the cloud is what we've seen happening over the last couple of years has mainly been driven in a change of focus on the financial side from CapEx to OpEx. So organizations don't want to go through the hassle of every 3 or every 5 years work on a CapEx budget to acquire an environment and deploy that environment, run it for 3 or 5 years, and then get to that entire cycle again. Very appropriate for the small or medium HPC deployments, not very deployable for the larger deployments, simple because of the scale and the fact that those workloads from a large scientific institutions being deployed in the cloud can be very diverse. So that's going to bring a lot of problems with it. That move from a CapEx to OpEx has been an initial driver, but what we see happening now is on the smaller and the medium sides, we even see them coming back from the cloud after spending some time in the cloud for a couple of years, and then finding out that running in the cloud is very interesting, is very nice, but you need to provision your cluster in the cloud with data, and you know, there has to be some model for those cloud providers to make money, and one of the big sources of income is data and data transfer. So finding out that is going to be something that is going to have a big impact on your operational cost, we see them coming back now.
We've heard that a lot as a proposed cloud benefit, converting CapEx to OpEx. But I don't know, I was dubious. You've always been able to do that just by leasing, right? that changes CapEx to OpEx right there. And we actually measured this in a recent survey because we were hearing it so much. And we asked end users in our survey, which of these is true? We're trying to move more CapEx to OpEx, or we're trying to move more OpEx to CapEx, or we're happy with the current balance between CapEx and OpEx, or we don't care about the balance between CapEx and OpEx. And 70% of users were in the latter two categories. Either they didn't care or they already had the balance the way they wanted. The 30% who cared, there were as many going one way as there were going the other way. So this idea that everyone's trying to create OpEx and can't, we're not finding evidence of that.
So there's one thing that is really driving HPC in the cloud adoption, and that is added value. You know, typically a deployment in the cloud from a money spending perspective for every user at the end of the line after 3 years or after 5 years has a higher cost picture.
It has to be added value because it's more expensive, right?
Exactly.
And what a part of
Exactly.
the added value is the flexibility that it has. We did just have this pandemic, in case people hadn't realized. Flexibility was required there. I have to get to Jean-Laurent and Yossi. Go ahead, Jean-Laurent.
So we know that HPC in the cloud has been great for burst. So that's perfect. We worked with a lot of end customers who thought that the nirvana was OpEx and that they could offload or put absolutely everything in the cloud. And some came back, as Rick said. I think that this is something that works well, but you have to find the balance between what you want to do and how much you want to pay for it, at least for the compute. But the latest thing that I have seen is that it's not too costly to send the data. It's not too costly to compute. And then you get a huge bill when you want to repatriate the data, which is a kind of abuse, I would say. I'm very sad for that. I think that people should know ahead of time that if they want to repatriate their data, then it will cost them potentially a lot. And I'm wondering why it is done that way. Maybe it's just a new business model, but I don't think that it's going to help move more into the pure cloud.
We were predicting this 10 years ago, that the fight was over possession of data, not ownership of data, but possession of data. And there's already a case study. Remember when these were free, right? When you could get one of these for free if you do a cell phone contract, and now they cost like $1,000, give or take. Why? Is it because the camera's that much better? No, it's because they finally made me use the stupid cloud. I used to have an in-home product that was an Apple time machine where I could back up and sync my calendar and all my devices. It was a private cloud. I loved it. Now they stopped that. You have to use iCloud. Now, what does that do? It increases switching costs. It makes it, if I want to put this down and go get a Samsung, Google, whatever, it's harder. How do I migrate all that stuff over that I've got in iCloud? And we're seeing the same thing happening with enterprise data. Yossi, you haven't chipped in on this yet.
Yes, thank you. I think that HPC in the cloud is great. Not every country, not every academical institute out there has a financial capacity to go and put a supercomputer in place. So to this extent, it allows for maybe entry-level, mid-level to go on the cloud. At NVIDIA, we don't really care. We support both on-prem and cloud the same way, so that's not an issue. I think the main thing is that how you're going to allow the on-prem having the same advantages that you can have in the cloud, specifically supporting for multi-tenancy and everything which has to do in security, east-west traffic inside the data center itself. To this extent, we came with a new solution named DPU, Data Processing Unit. It allows for zero trust inside the HPC cluster, and it can support multi-tenancy. I'll talk about it later if we have more time. But I think altogether, in the cloud is a great thing.
And I think it's here to stay, but we do see it leveling off toward an asymptote where it's not going to keep growing faster than the market. We're going to get to where what's a more stable long-term proportion of HPC in the cloud. And cloud growth, by the way, is starting to slow down. In case people didn't notice, roughly 100,000 layoffs coming out of the hyperscale market over the past several months. That's, the growth rate slowing down. It doesn't keep going to infinity. Let's hit some of these other lower down things, though, about managed services like these HPC as a service or facilities outsourcing and the role of these cloud-like kinds of environments. Olivier was already talking about it with regard to GreenLake. I should go down to the end and get Ryan and Rick. You've each got services around that, and you must work with some of the others who are out there in terms of facilities outsourcing as well.
Yeah, typically what the TrueScale proposition from Lenovo is a proposition that anticipates that additional value that's being expected from our customers. And that typically translates into something that is very often also created by the extremely aggressive growth of hyperscalers, and that is a lack of good skills in your operating environment to run your systems. So one of the things that we see separate from the balancing act on having an on-prem and an off-prem capability for bursting is that the capabilities around it for managing the infrastructure, deploying the infrastructure, and getting rid for the customer of the hassle of having to have skilled people in-house.
You're talking about skills with respect to the facilities and administration or application skills?
Mainly to the operational side of it, because the application side is something that is their sweet spot. That is the customer sweet spot. That's their applications that they have been building for many years and have been maintaining for many years. So on the operational side, we see a lot of demand and interest for the covering the operational side in collaboration with the customer in an on-site, on-prem, or even in a hybrid on-prem, off-prem environment.
So from a Dell Apex perspective, that is our brand name for our cloud offering, and it's pretty much covers our entire portfolio as a service. So there's a few different things, but what we've focused on, and for the purpose of this meeting, we've got two offerings in the HPC space. So we've got a Dell Apex subscription model for a reference architecture for life sciences, or as an example. Those allow us then to have a subscription-based model where the customer has a choice of whether they hosted in a co-location. I know in the US we've got Equinix. Locally we're working with Terraco and a few others. Giving the customer choice again whether they wanted to be fully Dell managed or whether they wanted to manage it themselves and just subscribe to that service and pay for what they used at that time. So very similar to what the hyperscalers are doing, but also allowing us to create standard operations from on-premise and standard management to allow them to burst also into public cloud space and manage them from a single Dell Apex console, which gives you that cloud-like experience at the end of the day.
All right, I want to move us forward to our next topic, and I'm going to let Yossi go first on this one. You heard me talking about this pendulum swing between standardization and specialization, and I'm maintaining that the next generation of SoCs on the market, you're going to have primary choices between an all Intel, all NVIDIA, all AMD kinds of environments, and what's the trade-off there in terms of performance for a given application versus things like management and portability? What do you think, Yossi?
So over the years, we've seen many startups and companies coming up with different solutions. And I think that the main barrier these days is the sheer magnitude of both technological and financial barriers. So there are two companies out there named GraphCore and SambaNova. For each spent something like $500 million in the new generation of GPUs, still with no revenue. And with a lot of respect, we're saying when we go from one architecture like Ampere to the next one, Hopper, we invest billions of dollars, and this is what NVIDIA did in the last 20 years. So I think, of course, there's nothing wrong in going and do a specialization, but I think the advantage of standardization, where you have the same ecosystem, you go new generations, you have backwards and upwards compatibility. I think that's a big plus.
Jean-Laurent?
I don't want to position standardization against specialization. Take AI, for example. In the Sapphire Rapids, so Intel 4th generation Xeon scalable processor, I said it.
Well done.
Good job. Yeah, I know. Yeah, thank you. We have brought the AMX accelerator, the Advanced Matrix Extension, which provides the basic capabilities for AI to use through the libraries into the PyTorch and TensorFlow frameworks, directly the capabilities of the hardware without having to change the software. And that's very important because in that case, you don't need to say, hey, do I need to buy this solution or that solution to do HPC or to do AI, but you can start with a solution that will work for HPC very well, for AI very well. When you get to the next level and you do a lot of training, then you might want to dedicate a little bit of your CapEx or OpEx to something which is more targeted at what you want. And when you do this for a living, like we talked about earlier, some of the hyperscalers do, then they might want to go to something even more specialized, ASICs or FPGAs or stuff like that. So there is room for that. However, hardware is one thing, and the experience that the end users have need to be maintained. And as Yossi said, we need to make sure that it is backwards and forward compatible so that the applications will run again in the next generation, can be potentially recompiled to take advantage of the new features, but so that it doesn't need to be completely reworked at the application level. So there is space for everyone. With one API, Intel is bringing this on the CPU, the GPU, and beyond, with all of the other architectures that are supported by the one API environment. And also with this being forward compatible with the XPU that I talked about earlier today, file controls. So yeah, there's room for everyone, and we care for the customers, the end users, and the developers. Some want portability, and that's the massive need at the moment, and some want, because they have one application, then they will be capable of using the specialized hardware for their application.
I'm going to insert a quick comment that I like one API and what it purports to do. I would like to see the statement about one API programming for things that aren't Intel processors like AMD Genoa or a Hopper GPU, right? If it's one API, let's get it out there, right?
So you, and I asked Yossi if he was okay that I talk a little bit about it.
You don't need Yossi's permission.
I'm respectful of people.
Okay, I'm not.
So as you might know, Intel has acquired CodePlay, and CodePlay is developing the level 0 API that will make SQL run on other architectures like AMD and NVIDIA. So this exists or will exist.
Yeah, I'm going to do all the system vendors going down now because you're the ones that have to put together these configurations. Go ahead,
but to answer, you can use one API, you can use a Cray programming environment as well. We are addressing all the SOC vendors, Intel, AMD, NVIDIA, and others. So being the exascale provider and being deploying exascale system, such Frontier and so on. So we are working with Intel, with AMD, with NVIDIA, like out in Europe, for instance. And what matters is not really the hardware. It's the convergence of the workloads to be able to use those new technology. Okay, and this is something we are developing and proposing. And we announced also recently, I'm sorry to jump to the last one, an initiative, which is we are building our own hyperscale solution. So it's called Ceres, and we will propose to customer different technology to test, to use before they will adopt it.
I appreciate the comment about Cray programming environment, but I think this actually speaks toward the problem of everything starting to get very verticalized or siloed within different vendors. It's nice to say I can manage my cluster with HPE and I can program everything with Cray programming environment. But the fact is, in our surveys, we don't see people using those HPE tools on non-HPE systems like ever. Like it doesn't happen at all.
We are talking about some cluster management needs to be tied into the architecture itself. So we are not talking about the programming.
Cray programming environment, though.
You have a Cray system. Let's take advantage of a Cray system.
I agree, but I don't see people using that on non-Cray systems.
I don't know.
Okay, well, that's the point of our surveys. Go ahead, Rick.
And that definitely is one of the very strong points of one API. You know, there's tons of our customers that are using one API in an Intel environment, in an AMD environment, in a hybrid environment, simply because on an ecosystem level, it's very beneficiary to have consistency and not having to live with multiple ecosystems in your environment. So we have Intel, HPC deployments, hybrids, but also AMD deployments that stick to one API as the programming and debug environment, simply because the fact that they were trained on it, they have the skills on it, and the performance also on AMD is pretty darn good.
All right, Ryan, you haven't had a turn on this one yet.
Yeah, so this one's quite an interesting one for me because I find the concept of the SOCs extremely intriguing. And working alongside Intel and NVIDIA, we just launched a couple of systems at SC a couple of weeks ago that are exactly around the ecosystem of
the Sapphire Rapids together with
100%.
NVIDIA.
So it's latest technology, some liquid cooled systems, some traditionally cooled systems. For the first time, we've got an 8-way system of being able to choose components depending on the problem you're trying to solve or the solution you're trying to put forward. For me, it gives customers the choice, which most of my customers like.
The HPC user community will agree with that. That is something that people like. All right, we got to speed up here. I hope you enjoyed how leisurely those topics were. We got to go twice as fast now. All right, I went to the Euro HPC Summit in May, and every other conversation was about quantum. Then I went to SC 2 weeks ago, and no one asked me about quantum even once. Is it time to talk about quantum computing or not? Your thoughts down the line. Go ahead, Olivier.
We are looking at it. So our labs are working on trying to put together workload simulation into a traditional HPC system to try to tackle those problems before going into a real quantum, which is today accessed by only few people.
You getting a lot of customers asking you for it?
No.
Okay. Jean-Laurent.
Intel has a lot of work going on in the labs, just like HPE. 10 years ago, quantum was 10 to 15 years away. Today, I can safely say that I'll retire before I'll see a quantum accelerator being used normally at room temperature or something like that in a supercomputer.
For every year we get closer, it slips back 6 months.
Or 15 years.
Yossi.
So I think it's not only time to talk, it's already too late. What we do at NVIDIA, we have a specific AI framework for what we call Q-Quantum, and it shows what's possible to do with the quantum. The way we see it, quantum is not going to replace the future data center as we see it, with GPU for accelerated computing, CPU for multipurpose computing, and DPU for mainly allowing for cyber east-west zero trust policy and storage acceleration. So from this point of view, quantum will act as a special accelerator for specific algorithms. And the modern data center will call on the quantum to run specific algorithms. And that's in a very simple way how we see the quantum advances. And as said, we have a library ready in NVIDIA, which is called Q-Quantum.
I love that answer. And I love when you get fast answers, there's no time for everyone to agree. You get disagreement. Go ahead, Ryan.
Well, I do agree with Yossi. And for me, the only thing is it's probably still a little bit early for locally from a quantum perspective. We don't have much conversations happening locally, but what's happening internationally and what we're doing from a Dell perspective, creating simulators, starting to understand the technology. We're working with other vendors like IBM and a few others in terms of standard or defining the standards of quantum. And I think the bigger thing is the ecosystem around quantum and how we're going to connect into these quantum systems. And I think Yossi hit the nail on the head. Seeing it in the early days is the next level of acceleration from our point of view.
All right, Rick.
So a couple of questions you asked. The first one is, do we have to keep talking about it? Yes, definitely. It is something that we need to talk about because it's something that's going to be very applicable to a specific workloads, like also Josie mentioned already. So yes, does it get enough attention? I guess my personal feeling is that it gets too much attention now because there is nothing concrete yet. You know, there is a couple of test cases that we have. If you put in your tender or RFP request, you use the word quantum, then you can ask for a couple of million more of budget. But is it going to deliver something? Not the coming 10 to 15 years.
Happy's good at asking for stuff. You should get a quantum system. You guys will sell Happy one, right?
Yeah, we will.
All right, good. Now you're ready.
You're not getting it, but ask for it.
Whoops, that skipped one. All right, environmental and facilities challenges. HPC keeps getting denser. It's more power hungry. How are we going to be able to simulate climate change without causing it? Let's see. We'll start in the middle. Yossi, go ahead.
So let me start with the fact on the latest top 500. The number one performing environmental friendly green cluster with the Lenovo system based on NVIDIA.
This is the Henry system, right?
Yes, based on NVIDIA, both compute and networking. I think that the challenge here is how do you create ever more better performance with net zero?
And where are we with that?
Working on that.
How long till we get net zero, do you think?
I think that's a work in process, but the expectations, everybody know that the cost of power is ever growing increasingly. The war in, it is a problem. So it's not only about, okay, get me the best performance out there. It's about, okay, show me how you can come up with the next generation HPC cluster with AI while you still get down on power consumption.
Jean-Laurent.
Power is a big problem. We used to measure data center efficiency in PUE, and I think that now we need to look at it from a different perspective, which is there will be heat generated anyway. Okay, I was at Chineka last week when they did the inauguration, and the hall where we were, they heated it with the heat coming from their Leonardo supercomputer. And I've seen a lot of the data centers that are reusing the heat to, or the heat to warm up some buildings or to help with agriculture where they need a little bit of glass houses with some heat in it. So I think that we won't stop the data centers to be asking for more power. 20 megawatts, 40 megawatts. You look at some in the Nordics, they are ready to host about 200 megawatts of power. The power is a little bit cheaper there, but the heat, if it is too far from a city, then they won't be able to use it to heat apartments and stuff like that. So I'm more trending towards a solution where we need to use the power which is coming out of the data centers and at the same time work on the applications so they are more friendly in terms of how much power they need to reach a certain level of performance. Maybe we can extend a little bit the time to solution by using a little bit less power, or do something like that. But we are working very heavily with plenty of our software ecosystem partners on solutions.
But we're in the shorter answer part of the panel, so we got to. And I want to hear what what the system vendors have to say, because whether or not your clients are asking you for low power in this. Go ahead, Ryan.
Well, being South African, be lucky if we've got power, firstly. So
your microphone keeps cutting in and out.
Yeah, so, but it's a hot topic. I think I've noticed globally it's becoming a hot topic around power consumption and how we can get more sustainable solutions out there from a power perspective. But I think our co-locators, these guys that are building these state-of-the-art data centers are really getting extremely clever in terms of how they supply that. We have our own internal software technology where we can actually apply power caps across certain systems so we don't overgenerate. But I think also, as technology advances, we seem to having a lot of focus around being power efficient, and that's always been some of the Dell stance is being as power efficient with a newer technology as we can.
Rick.
So let me start with tomorrow, half an hour pitch on how we're getting there. So if you're interested, we have a roadmap.
Don't do a half-hour pitch now, but a commercial for it now.
The answer is yes, we can get there. At the moment, we've been doing this stuff now for 10 years with warm water cooling. We know what's required. We know what we need to do, and we also know what we need to do with customers. The biggest issue we have now is legacy on the data center side. Data centers that have been constructed 15 or 20 years ago that can provide power of 15 kilowatts or 20 kilowatts to a rack, that's not applicable in this environment. We're talking about racks now already that are 80 kilowatts on a normal 42U rack or over 100 kilowatts if you're using GPUs. By 2025, that's going to be 150 and 180 kilowatts. So we need to act now. We need to step up the work that we're doing in the data centers. We're efficient now, 98% heat transfer to water. That 98%, that hot water of about 60 to 62 degrees can be used to heat buildings, to heat swimming pools, to heat whatever you want to heat, but also can be used to create cold water, to just cool those few racks that you have in your data center with storage and with network switches. So that is free cold water, no chillers are needed.
Olivier.
Fully agree.
That was good. We do.
Facilities is a bottleneck today. Most all customers, okay, and the capability. We know they have to go water cooled. That's the trend that our friend here, Yossi and Jean-Laurent, are driving the market, okay, and others. And the bottleneck is
yeah,
no,
right.
It's more performance on the same die, same die, and so there is no magic. It's physics, okay. So more power. It's how it is. But then the problem is most of our customer, maybe not here, but in many regions, is the facilities is not managed by IT, and they don't care. They are mainly telco people, and lucky if you find a data center 15, 20 kilowatts. We are more looking at 8 to 12 kilowatts, and we have to fit HPC and AI infrastructure into that.
And many of them are not plumbed for liquid cooling. So we do see door chillers as the most common implementation of liquid cooling in our surveys. People are trying to add it now, but the data centers, to your point, with legacy data centers, we didn't see it 20 years ago. It wasn't as common. All right, national sovereignty in HPC and AI. It's one thing to think of HPC and research as this borderless scientific community, and can't we all get along? But as an analyst, I can't help but see this kind of looks like here's this American effort, here's this European effort, a Chinese effort, a Japanese effort, an Indian effort, and they're all on their own tracks. What effect does that have? Does that reduce collaboration? Is that a right or wrong path? Where's this taking us? Ryan, you were nodding, so I'm going to call on you first.
Yes, I think lost my train of thought there.
South Africa are going to have its own national initiative,
I think
for everybody.
We demonstrated, the student cluster competition. I think competition is good. I do believe that the US have been driving this market for some time. I do know Europe is trying to define their own kind of standards in that space. China obviously trying to get in on their side, developing processes and trying to get on that side. So it does create these different types of competitive markets, and the guys have got to develop in that sense. So that's.
Yes, walls are being built at the moment, and that is going to have an impact on everybody. It's going to have an impact on what we do as a vendor. It's also going to have an impact on what our customers will be seeing. From a Lenovo perspective, we have a development of our systems across the globe. We have manufacturing across the globe. Still, even with manufacturing across the globe, you're going to run into situations that, for instance, by US law, that shipment of specific accelerators to some of the regions is not allowed anymore. So we need to be flexible enough to adopt that and adopt the manufacturing in like a factory in Budapest or like a factory in the US, which is what's happening. So we're flexible enough simply because we're not ruled from one country or from one region, but it's more federated organization than anything else.
Jean-Laurent and Yossi, I mean, you're the ones who have these components that he's talking about.
So in terms of sovereignty, you know that Intel has decided to invest in Europe to build a fab. And by the way, as of 36 hours ago, we signed the contract for buying the land. So now it's done.
Congratulations.
450 hectares close to Magdeburg. So we are rebalancing the manufacturing facilities across the globe. We are working with the European community and especially with the Euro HPC JU on working with RISC-V based solutions potentially. And as I talked about Falcon Shores earlier today, I alluded to the fact that potentially at some point in time, the CPU chiplet could be a RISC-V chiplet. We also announced a collaboration with Cyper, so that opens up to more sovereignty in Europe. But I think that it's just not easy for then the OEM partners that we have to decide which solution they will have to support. Can they support them all? Is there a market for them all? That's the first question. Economy of scale, as we discussed earlier. Second, would it be good for the scientific community? Potentially, if there is portability across all of those sovereign solutions.
Yossi.
So if I'm to share personal opinion, if you read the likes of Fortune or Time or Newsweek, we might go into a world where there is going to be a firewall between whatever is happening in China and whatever is going to happen in the West world. NVIDIA was very impacted by the war in Russia. We just lost the Russian market, like many others around here. What happened with the US government, and I'm putting facts only, inflicting specific licenses so we cannot sell in China anymore, the latest generations of GPUs, and on and on. Beyond that, the official NVIDIA statement for this one, I was advised by our legal to say, we're a technology company, we sell to all according to local and international regulations.
Olivier. Well done, Yossi. You got it recorded too. That's no, you followed the rules. See how well he behaved, Happy? Go ahead, Olivier.
Yeah. No, I mean, I think he has been in South Africa, no jet lag since many days now, enjoying it. No, we do it in three ways. So we have user club, one from legacy HPE, which is called Forecast. So gathering international customer all together and being able to put them in a room and share and talk with them about technology. We have also still the CRE user group also. So having all the academics, customer using legacy CRE and newest generation together for a week and sharing experience and how they can collaborate together. And then also we have in Europe an organization who belongs to our business unit, which is creating collaboration at the customer level, allowing what we learn over the world to be utilized locally in a nation.
All right. Last topic before the close, talent and workforce development. This came up earlier today, but was said basically in the morning presentations. If we're going to keep chasing innovation, we need to keep cultivating new ideas. We heard about fresh legs and new minds in this space. And that's going to include both youth and a diversity of talent. If we want new ideas, they've got to come from more places. Diversity is something we did a really poor job of on this particular panel. And I'd love to acknowledge that right out of the gate. We could have done a better job with that. We didn't. Not that I don't appreciate each of you individually. I do. But if we're going to model diversity in this industry, it's something that we really have to take an active role working on. Each of you give me a quick hit on this topic. And Jean-Laurent, you get to go first because I loved those awards you announced this morning.
So I cannot be more happy to be here and hear Dr. Happy Chitori say that we are going to help create the next generation and encourage them. I've already spent some time with the teams working on the cluster competition, and they are brilliant. Yet we don't get enough of those people. The engineering schools don't put the right focus on AI or HPC at the moment. As you may know, we have announced that we will be creating a lab, an HPC lab and IFS lab in France for 450 people before the end of 2024 and 1,000 by the end of the decade. I know that we're going to struggle getting the right researchers on this topic in this lab. That will be really hard. So we are already starting working with the engineering schools in France to tell them, hey, do something. We are ready to work with you to prepare and have some curriculum that will help towards this. Now, how soon can it be? I don't know. And we hope.
Takes a long time, but it's worth cultivating. Olivier.
I'm encouraging you to attend tomorrow, Trish Damkruger talk about diversity, women in HPC. Okay, it's a follow-up of the talk she had in 2018, and she will follow up now, only now because of the past situation, of course. So this is something very important for us, and we have a huge, intense internship program inside HPE South Africa office as well. So we take it seriously.
Yossi.
I'm a bit surprised that my two French colleagues next to me didn't mention that as far as diversity in this Mondial, this is the first time in the history that the judge is going to be a female, and she is from France. And I think that it's great testimony for even though the FIFA is not the most innovative organization out there, first time in the history, a judge female and from France.
USA is through.
Specifically, our HR goes very strong into diversity. We invested heavily recently in two specific locations. One is in Cambridge, the Cambridge One cluster that NVIDIA contributed to the UK, which is now servicing dozens of British companies out there. And there was specific clause into diversity in this one, and the other one in Germany, our Executive Business Center, which had the same clause. Altogether, we're making big efforts to have as much diversity, regardless of skin color, gender, etc.
Ryan.
So yeah, from a Dell perspective, we focus quite a bit on workforce transformation and how we enable the younger generation to adopt technology and see how that fits in. I think in terms of generating talent, we work quite closely with the CHPC, where we established the Kalisa Academy some time ago, which is specifically taking previously disadvantaged youth and training them up in HPC specific technologies. And I think we need a lot more of that. And to Jean-Laurent's point, working with the students out there, it's amazing. These guys are really super clever. I think there is a distinctive difference that I noticed in building up to the student cluster competition is certain of the universities have got clusters at the premises that they're able to leverage and learn, where others have to come here and put it all together and kind of learn on the go. So, if we can bridge that gap and they could get more into it before they come to competitions, it'll definitely help in terms of talent development.
So, one thing we need to start doing is influence the younger people. at a very soon age. I saw a very nice example here with the young people being influenced and being involved and engaged with high performance computing. It's also kind of our responsibility, is it, to make sure that that HPC is being seen as something hot also by younger people, and not only by old people like I am. Young people need to see a future in it, and if we don't market or sell it properly to the younger generation, then they're going to stay away. They're going to do other interesting stuff. So it's up to us. We need to get into academic institutions, into universities, into high schools, more promoting what HPC is, what HPC brings. You know, it is something that helps us solve humanity's greatest challenges.
Totally agree. And from our perspective at Intersect 360 Research, I will put in a quick plug that thanks to Dan Olds, we are about to head into our third annual, our own student cluster competition, our Winter Classic Invitational. It's a virtual student cluster competition that does outreach specifically to historically Black colleges and universities, Hispanic serving institutions, and traditional women's universities in the United States. Now, that's a somewhat American perspective, and what racial diversity looks like is going to vary depending upon what part of the world that you're in. But these are universities that get otherwise dramatically underrepresented on the conference circuit. And I'm really proud of Dan that he did that. I'm glad that we're able to keep supporting that at Intersect 360 Research. Okay, just a few words, quick wrap up. If you were the analyst and someone was asking you what's the most important trend to watch in HPC and AI in the years to come, give me a quick 30-second answer. What's your elevator pitch you're going to tell a client, Rick?
I don't have my glass ball with me at the moment, but what will happen is that we going to see more density in solutions that need to be integrated into the same square meters that we have available in the data centers.
Get ready for higher density, says Rick. Yeah. Go ahead, Ryan.
I say get ready for some really innovative software solutions over the next few years that'll even more, make HPC available to more vertical industries rather than our traditional industries.
We've got the hardware, bring on the software. Yossi.
You ask what's next. I hope what's next is a very good dinner with a South African ribeye with a very good full body pinotage.
The braai.
But further on, I think it's, as we discussed before, higher performance, zero net, and a big emphasis on optics.
Optics, I like that answer. Jean-Laurent.
3 seconds, work on the portability of your application.
Portability, we talked about that before. Olivier.
Convergence of HPC and AI workloads, ability to have multiple type of user, HPC traditional user, AI data scientist, and business analytics being able to use the same system.
Well, I hope all of you got to enjoy being an analyst for the last hour. Thank you for joining me up here. Please join me in thanking our panelists. How did we do on time? We came in right at the allotted time. Are we going to take questions from the audience, or did I use up all the time and we can't do that? You're the boss, Happy. Would anyone in the audience like to ask a question? They're trapped up here, so you got them. Maybe you're going to luck out and you get to be done.
Quite a few.
Yeah, repeat the question.
Is how many HR training courses we must take at NVIDIA? Quite a few.
Yeah, you have to get trained to take a mic. Okay, thank you again to all my panelists. Thank you to oh, there's a question. I'm sorry, I couldn't quite hear the question. It was to do with cloud in relation to big data. What was the question again?
So the question is, we wanted to get a level of cloud versus on-premises? That was one of the questions.
Yes.
Wondered whether we should be asking that question today, or we know that that is what's happening now.
I see. So you're making the point that it's already leveling off, that we're already seeing a leveling off of cloud with regard to on-prem related to the amount of data and the practicality of moving it in and out of the cloud. Did I get that right?
Yeah, that's what
Any further comment on that, gentlemen? I think we kind of covered it before.
I think that's kind of the answer I gave on
Yeah.
the cloud and why we see people coming back to an on-prem deployment.
And we, from an analyst perspective, we are seeing a slowing down of the growth rate of HPC in the cloud. It's still going to look high from a total year perspective for 2022, but you have to remember that's a total year perspective. And in the first part of the year, we still had a lot of COVID and supply chain uncertainty in a lot of parts of the world. It is slowing down rapidly. And in the next couple of years, we'll get to where cloud is really just matching on-prem at an industry growth rate, not growing any faster than the rest of the market. Okay, that's our time. Please join me again in thanking the panelists. Thank you, Happy and Vernon, for having us as usual.